So what I've got on the bench here today is these grow lights. So you've got the 3 heads, and you've got this clamp over here, table clamp. So what it comes with is this control for running it, for controlling it, on and off timer, whether you want just red, just blue, and your brightness, and it runs off USB. So what I need to do is hack this, because I intend to run this off the real-time clock of my hydroponics irrigation controller. So I'm going to set that aside like that. Let's see if we can get into this controller without stabbing ourselves in the process. So the idea is to use this relay similar to what I'm using for the pump over there. Yeah, all the good blue areas in shot. Okay, we're good. So we need to get into this. Okay, alright, we managed to not stab ourselves, which is a miracle. Right, so there's the FETs over there, and quite a big jumble of wires. So what do we got? 0 volts, red and blue, and our supply. So I think we're going to leave this alone and just detach the wires from it. So I didn't switch the iron on, bad planning. So I've got all the switches over here, some surface mount jobbies, and a little microcontroller. So while we're waiting for the irony to warm up, no, there's no markings on it. The usual AO91 fits for controlling the LEDs. Now what one could do is get at the gates from the Arduino and just control the gates, but I'm just going to keep it simple and use a relay. Right, so the iron is hot and bothered, so let us desolder. I'm going to keep these aside. Maybe not. Okay, that obviously molded over. I think what I need to do is put this in a clamp to make my life easier and make this video less fiddly. So let's get this clamp organized. Like so. Right, then take this board, clamp it in there, and get some tweezers and do a bit of tweezering. Alrighty. We have liberated the wiring. keep this here for now. But now we need to do a bit of wiring. So let's move that away. Kind of over there. In fact, now you guys can see through the lens as well, which is nice. You can actually see what I'm doing. So what we're going to do, so you want to extend these wires let's see what's going to be the easiest. Let's get some wires like so. Let's get a bit of black wire. So what I'm going to do is I'm going to leave them long. I'm going to leave them long. I'm not going to cut them short. So we need 3 of them. Leaving them long means that I don't have to try and have stuff piled up close together. So I'm busy untwisting the wires off camera. So there we have that one. Let's do this one. What I'm doing is just grabbing them like that. Like so, and just twisting them apart. So these are twisted pairs. So presumably a bit of comms cable that I got lurking around. Alrighty. We have wire. Now we need a cable stripper. So let's start off with the white one. What I'm going to do, I need to set the tension down a little bit. Let's knit a few strands off. Let's turn that tension down on the jaws. That's better. Okay, let's put this in here. Let's start off with the white wires. So I will afterwards put shrink sleeving over this. So what we're going to do, see if we can wrap these around. Like so. I think that it's a fairly nice day out. So the nearby airport is out doing flying lessons, so that's what that aeroplane is probably about. You can hear it's a Cessna 172. So that would have been a school plane. Could have been somebody in his own plane as well. So that should be good enough. Unfortunately, that clamp is... Unfortunately, you guys can't really see too well through this lens. I do apologize. And now we're going to go for the red ones. Let's use a grey wire for that. Actually, we only need 2 wires because we're going to... Nah, let's go with 3. Keep the red and the blue channels apart. We may just, for some reason, want to control the blue and red channels separately. So why not? There we go. Give it all the solder. That's that one done. See if the shrink sleeving fits, otherwise we're just going to use insulation tape for this. Right, and next one. Yeah, they're all 3 there. Kinda. What I'm doing is I'm stripping it quite long and then just wrapping the wire around the 3 wires from the LEDs to hold them together, and then adding solder. Trying to not melt my fingers. Alright, let's see if this stuff is going to work. It's a bit small. Let's try and find out. Otherwise we'll use some insulation tape. We've all done it. Right. That one's on. Let's start with this one. What I'm going to do, just clip off a bit of the joint to make it smaller. Get some more of this stuff. Now we need this wire. Like so. Good. Now I need one more. Clip off a bit of the joint. Now it should fit. Bit of sleeving. And that's the remaining wire which is tangled. Then we're going to do the same with the supply. Now what I'm going to do is do all the soldering. Once we're happy with our choices, I'll go ahead. So black. Okay, now this red would have gone to red. What I'm going to do, let's see if we can get a power supply going here. Let's strip these ends. So red is grey. And what I'm thinking is that these two so you guys can just see the light against the wall there. So that's red and blue. That's both together. One and a half amps. I'm thinking that's a bit of a tall order for a USB power source. So what I'm thinking, why don't we use the buck converter? Of course I'm using about 8 volts for the pump. Maybe I'll do the same for the LEDs. Get a buck regulator and let it live off the 8 volts. Of course I planned this really well, so now I'm digging around for a buck regulator. We will find it shortly. Or not. Now the USB power supply that I've got is good for 2 amps, but I'm not all that wild about the idea. There's one I'm running 1.5 amps and my Arduino off that. Wasn't terrible. DC to DC. So if I connect that like that, 8 volts. Let's get a multimeter, a multinational tester. Let's see what we're getting out after untangling my leads. See if we can turn that up a bit. Of course the pot works the wrong way around. Why would it work the right way around? The nice thing is that I can adjust the intensity of the LEDs by using this regulator. That is another benefit. Okay, we got 5 volts. Good. Right. Set that aside. Okay, so what we need is we're not going to use the USB anymore. So that wire can go away. So we said the red wire needs to go to positive. Okay, so I think what I'm going to do is switch to positive. This is one of the longer format videos. For those who just want to sit with a cup of coffee and spend some time learning how to do stuff, this is a how-to video. So there's that relay. Wired up to there. Okay, what I want to do is so gray goes to the relay, that's positive, so we need the negative out. So let's solder that. Alrighty. alrighty, and this attached. And then we need positive out to the relay. Use the correct tool. It's a black wire, but that's okay. As long as you pay attention to what you're doing. Remember what's what. Do this one. And then we need to attach that to the positive output. Need a bit of solder on our wire. And onto there. Okay, now a little bit more to do. While we're at it, I'm going to sort out our pump wiring. So let's take out this. This is our pump relay. I have some wire. So let's need to get another roll of that from downstairs by the looks of things. So let's start off with these two pieces. Solder it into the power supply. So that's that one. And attach that one. Good. Now we want that to go to the relay, as well as some red wire. So I'm going to see if I can get them both into that terminal. Let's see how this works out. common as the middle one. Right, get them tightened down. Right, that it's going to go to two places. It's going to go to the pump, and it is going to go to the supply. That too. Let's do something about the shrink sleeving. Got it over here. Let's get that shrunk. Good. That's it done. Put that next to the oscilloscope. Okay, that's done. So at this stage, now the other thing we need a connector for this relay. So I'm going to wire that to the Arduino. So let's check the LED operation. So that works. Now I'm going to take a piece of wire. Now I see we're only drawing 1.12 amps off the power supply now, because we're using a buck regulator. Which doesn't even break a sweat. Good. Okay, so I guess you can put that aside. We don't need that anymore. But a perlite floating around there or something. Yeah, it's perlite. So what we want is our Arduino back and the display. Like so. What we only need is a real-time clock. Just needs to plug in like that. Okay, I'm going to put it here. So what we need to do is it needs to go on the I2C bus. That'll be clock and data. So 4 is data and 5 is clock, as I remember. Then we need some 5 volts. So the 0 volts is the white wire, so stick that in there. Okay, now the jumper. Then we need more 5 volts for our relay. So I'll stick them in there like that. And so ground is that one. VCC. Going to use pin 8 to drive the relay. So we're going to go in like that to pin 8. And then we need the I2C. Let's see what do we got. We got orange and a green wire. So A4 is data. A5 is clock. Right. Let's check that. Good. So the I2C bus is alive. Our relay is ready. So now we just need some code. Turn the irony off. So now we just need to drive this relay. So that it works our lights, which are wired up. Let's just check that once again. Yep, the lights work. There they are over there. I think they're in shot now. So I'm going to fire them up. Yeah, you can see them on the top right of your screen. Okay, so now we just need the RTC to work the lights. The pump is working because I've got the 2 pots for dwell and pumping time. So that's working. We're all good there. So let's look at the code for this. Right. Move the microphone over to that side. And let's flash up Arduino. And my programming assistant known as ChatGPT. Right, so that's flashed up. So what I need to do is what do we want to turn off? That. Let's move this over here. That over there. Now you can see the code. Very good. You can hide that. Later. So what I'm going to do is copy this code. Let me just turn my mouse highlighter on. Where is it? There we go. Now you can see the green dot and you can see what I'm doing. Bring that closer. Alright. Let's select all this code, copy it, paste it into ChatGPT. What we want to say? Well, first let's start with the question. Hi there. I am adding lighting control to this project using the DS1307 RTC. The output pin for the light relay will be 8 on the Uno. Here is the existing code. Paste, enter. In the meantime, let's just create another project here. So we know Control Shift S. With RTC for lighting. Okay, just had to shorten the file name a bit. Alrighty. Yes, I forgot to tell ChatGPT that I want 12 hours, but it figured it out. So let's have a look at what it has done. Let's drag that over here. So need the RTC library, initialize the RTC, read the current time, compare the time to your lighting schedule, 6 till 6. Use pin 8 to control a relay for the lights. So here's how it's broken it down. Include the DS1307 RTC, light is pin 8. Initialize the light pin in RTC. So the light pin is an output, digital write it low, which we want. RTC begins, set cursor, that's our LCD. Then in loop get current time to control the light. So if hour is bigger than 6 and hour is less than 6 p.m. write the light pin high, set cursor to position 10 on line 2, print light on, else digital write light pin low and show it on the display. So add to the top of your sketch that stuff, RTC lib, DS1307 light pin 8, and set up the stuff for the pin, the light output pin and the RTC, and then in loop before LCD updates we add this bit of code. So let's do that manually, although I could get ChatGPT to do it automatically. Let's not be lazy and let's do it the learning way. So first of all we need the include file, so we're going to paste that in. We can make those go away, we know of those, it's compiling. Define the light pin, so we copy that, we're going to add that over here. Next we want to set up the light pin and RTC, so we're going to copy that code. So we're going to set up, paste it in, tabulate it, good. Then we need to add the loop, so I'm going to copy that, go to our loop, make some space, paste it in, Control T to tidy things up. Let's see if it compiles. It has compiled. We are online. No, we're not. Let me plug the Arduino in, because I had it running off a USB power supply. So it should appear here now. So now we can upload. Alright, let's see what's happened on the workbench. So we go over here, turn that on. Let's see what happened. The light on output is on because it's running the daylight, the pump during daytime, the light during daytime. Let's move the mic to sort of a general position so you can hear me. Green is the control, and what have I done here? The ground, I've mixed them up. So what we need to do, there we go, that has come on, and so have our lights over here. Right, so that is working. light is on. So now if I take the part for dwell, the pump has come on, because what the code does is it if you set that down over there while it's busy counting down for the pump dwell time, it if this dwell time becomes less than what was left for the dwell, then it starts the pump straight away, and then after pumping it resets that. So the pump should turn off here shortly. You can see the LED over there. Got a few seconds left. Yep, she's off. And it is saying 2 minutes. Now what I've noticed is that this is a bit busy and we don't have enough real estate to do everything that we want to do here. So why don't we add a push button to toggle between screens. So the blue wire is going to go to pin 9, and then I need some 5 volts for it. So let's see if we can steal that over here. So green wire is 0 volts. Let's put the 5 volts in first, because it is getting busy here. Put the 0 volts in. Right, so now we have a push button with which we can toggle between screens. So let's go back to the code and fix that problem. Just going to move the mic back to the PC area. Okay, so let's turn the bench off. We're back to our code. Let's hide OBS. Right, let's talk to ChatGPT. Let's go back here. Let me show you what I'm doing. That works nicely. Thanks. I have added a push button onto pin 9 of the Arduino, so that let's make that an S. I can toggle between 2 screens on the LCD as it has been busy and I would like to spread it over 2 screens. Could you please update this code for me? Now we go back to there, copy this so that we and show ChatGPT what we've done, then it can look at it and it can add our code for us. So there's the updated code. So we have got button pin 9, which it's added. Last button state, current button state. So that's button state. We have got the page control. We've got our setup, which is pretty unchanged except for the button mode. Pin mode pull up. The button is to low. So could we just change the code to suit active high. Button is active high, so it could be please change the code to suit. Okay, let's try that again. Even when you're using ChatGPT, it's an iterative process. So what we're going to do first of all is copy all of this code back into our project. I'm going to move that over. It's going to move that line down. Control A, Control V. Right. Now we know there's some changes needed. The two changes we need. Bin mode. Button. So we need to change that. So it's an input external pull down resistor. Good. Then in the loop, the button state is high. Current button state. Okay, so it's given us a modified section of the code. So what we want is that. Okay, let's see if that compiles. Okay, let's bang it in and see what happens. Alright, let's change to that screen. Let's see what has happened. Let us have a look. So currently pump time is 58 seconds, dwell 3 minutes, light is on, time is 11:17. Yep. status is wait, not pumping. The remaining dwell time is 2 minutes 22. The light's on, page 2 of 2. Yeah, that's working beautifully. There you can see it over there. Very good. So now we have control over our light. And adding a push button enabled one to scroll through pages. So let's have a look at the code one last time. Then we're going to wrap this project up. Then I need to take this mess and go put it in a sensible place because we can't leave it here. Let's have a look at the code. Alrighty. Code wise, Y.8 liquid crystal .8, that is your I2C for your LCD display. RTC lib.8 is for the real-time clock. Liquid crystal is address 27. It's a 20 by 40 display. The pump pin is 7. The dwell pot is a 0. The pot for pump is a 1. The light pin is 8. Button pin is 9. So here we got some timing variables. So this is in milliseconds. So to get to 1 minute, we got 60,000 milliseconds. And to get to the pump time, we are working in 1 second increments. So that is 10 seconds at a time. 10,000, yeah. There's your counter, previous milliseconds. Boolean for pump running. An integer for remaining time. So button state is high. Now I'm going to change that to low for now. Yeah, that's better. It still worked, but one should tidy your code up as far as possible. Current button state, that's for the demouncing. And the current page, which page you're on the HMI. And there's your values for LCD optimization. Pump pin is an output. Write it low to start off with. Light pin is an output. Write it low to start off with. Button pin is an input. RTC begin. Set cursor 0, 0. If the RTC is not found, it warns you. Right, initialize the LCD. Write hydroponics timer. Wait 2 seconds, clear the LCD. Date and time now. So what that does is when you compile, there's a time and date stamp on the compile, and it will write the time and date stamp when you compile to the RTC straight away. So that's what that line of code is doing. So that's how you set the time and date on your RTC. The code does it when you download. If the hour is more than 6 AM and less than 6 PM, digital write light pin high, else write it low. So that's the clock task. It's as simple as that. Your button pin is being read here. Your debouncing is being done. And then here's your page control over here. The analogs are being read over here and converted from 1024 to 1 minute or 1 second. It's got milliseconds and milliseconds. Is your timer. And that's where it checks calculate remaining time. Okay, that's where it does the sum. Display handling. If current page is 0, display that. Else display that. Now, if you had more pages, then it would check for the page number. Of course, if you've only got 2 pages, it's using a if else statement for that. So these are 2 pages it displays. And depending on what's going on with your light, well, it shows the times, it shows the status of the pump running, status of the light and that sort of stuff. Oh no, I was wrong. So that's the whole page 0 and that's the whole page 1. Okay, so it has split them up. Nice. Interval control logic. If your pump is timed out, it turns it on. That's the dwell time. And once your pump running, okay, this is only for the pump control. So when there's time left on the pump timer, sets the pin high. Once that time has run out, it sets the pump pin low. So that's what's going on here. As you can tell, I'm reading this code for the first time. In detail, that is. Because that's how we roll with these things. But it's okay. Now it's nicely written code. It reads well. It's properly commented, proper variable declarations and that sort of stuff. You know, anybody can work on this code, and it's working code. And so, going back to our project, let's switch back to that camera. We're going to wrap it up here at the bench. So let's do a quick recap. I've got these lights over here, the grow lights. We wanted to run them off a higher voltage from a more powerful power supply. So what we have over here, ow, that's hot. Okay, it's steaming a bit, but that's okay. It's probably at about 60 degrees C or so. So you probably shouldn't do any more than that. Yowzers, it is steaming. Okay. Switch mode power supply for the lights. We've got a relay for the lights. And over here, that's currently on. We've got our pump relay. Now pump runs off the 8 volts that comes into the switch mode power supply. We've got an RTC over here, which turns our lights on during the day. We've added a button which toggles between these two pages, and on the second page it tells you which page you're on. Currently the pump is on as well, because I got the dwell pot set to minimum so that we can see the pump running while we're doing this video. So we've got 2 pots over there, so that's analog 0 and 1. 4 and 5 is being used for the I2C. Okay. We hooked up our button to pin number 9. Number 8 is driving that relay. 7 is driving this relay over here. In a moment this will turn off, and then we'll go back to page 1. Right, there we go, it's off. So, where's my screwdriver? So, there you can see the dwell coming up. So the dwell, I want to set to 30 minutes for now. And I'm going to set the pump time to half a minute. That's enough to wet the perlite. Like so. Light is on, and there's the real-time clock time. It's almost lunchtime. It's time to wrap up this video. Right, it's been a long one. We got a lot done. Okay. I might consider changing over to the switch mode, given that I'm grilling that one a bit. But I'll fix that off camera. But I see this one's complaining about the 1.5 amps that we're pulling. I think we should only be pulling about an amp through that without cooling. So we might change over to this one instead. We're not going to leave that like that, because we're decent people. We don't do things like that. We don't leave projects half finished or about to catch fire. Also, I've currently got a 5-volt pump, well, it's a different pump in the hydroponic solution. This is a 12-volt pump I had in originally. Now what I need to do is 3D print an intake screen for this, because what happened is this ingested some perlite and it jammed the impeller and the thing stopped pumping. When I took it apart, I found some perlite inside here, so I need to 3D print a screen for this so that it can't ingest solids, because this is a more powerful pump than the 5-volt pump, and I need the water flow, so I do need to put this back into that pot. So that's another thing that I need to fix. And then I 3D printed this trellis. I made them with holes like so that they're stackable, which is going to go into the pot so that my pea plant can grow up on it, because the pea plant is already sticking its leaves out. It's enjoying life. Yeah, and that's where we're at with this hydroponics project. These things evolve, and I'm sharing it with you, and it's awesome. Right, time to go. Have an awesome day further, ladies and gentlemen. Thanks for being here. Thanks for watching the video, and I hope you learned something during this long video. Awesome. Right, take care. See you next time. Cheers.